All right, this week we are going to be looking at Unit 4 and conditionals. So this kind of gets into the start of us being able to add some logic to our code so that we can make decisions. So we're kind of still using these visuals here where we're using the Ziploc bags to represent a variable, and then we have the post-it notes that are going to represent the values that we're going to store within that container of that variable that we're creating. So same as before, we got yellow post-it notes for numbers. We have pink post-it notes for strings. We are introducing a third type of data now, and that's going to be a Boolean. So Boolean is basically true or false. All right, so we can store the value true or the value false, and then do some logic with that to decide whether or not something's going to happen or it's not going to happen. So we're going to kind of walk through this a little bit and then kind of get into the weeds on it. But basically we have these expressions, right? So this one's just saying, is 3 less than 8, right? So 3 is less than 8, so that's going to evaluate to true, right? So again, this is our Boolean expression now. It's not just an expression, it's a Boolean expression because it's going to evaluate to either true or false. To do this, we have these comparison operators. And this should just remind you of your math class, right? We have less than or equal to, greater than or equal to. We have equal to. So in coding, if we want to see if one side is equal to the other side, we use 2 equal signs, not 1. That's really important. All right. If you're checking if one side is equal to the other side, you need to have 2 equal signs, not 1. And then our 6th comparison operator is not equal to. So if we use the exclamation and the equal sign, that is stating is 3 not equal to 8. Again, we call these comparison operators. So just like in math, we have the order of operations. So we need to evaluate one side before we can evaluate the Boolean expression. So here we have 3 plus 6. 3 plus 6 is 9, so it's saying is 9 less than 8. So we're going to get false. These are just some more examples, right? So 6 minus 3 is 3. 4 plus 1 is 5, so is 3 less than 5? That's going to be true, right? 12 divided by 6, is that greater than 3 minus 0? So we have 2 greater than 3, that is false. Here we're going to say 7 minus 3 is 4. 4 times 3 is 12. So is 12 less than or equal to 10? That is false. And then this last one, we have 9 plus 5. Is that equal to 4 plus 10? So we have 14 equal to 14. So that would give us true. All right. So like I was saying earlier, we can combine this with our variables. So in this case, we have the variable lives, which has the value of 5. And then we have this variable score, which has a value of 10. So we're saying is lives plus 4 less than score minus 1. So we know lives is 5, score is 10. So we're saying is 9 less than 9. Again, 9 is not less than 9. 9 is equal to 9. So this expression is 9 less than 9 will evaluate to false. So this is how we can start making some decisions in our app, right? So let's say we're going to ask the question, can I go to the movies? And we're going to say, I'm allowed to go to the movies if it's before 8 o'clock. And what you're going to start seeing is this flow chart. All right. So basically we have, the question is what time is it, right? Because if it's before 8 o'clock, I can go. If it's not before 8 o'clock, I cannot go. So we are going to just pretend like it's 9 o'clock. So our variable time has a value of 9. That feeds into this diamond, right? So anytime you're looking at these flow charts, the diamonds are your decision. That's where you're going to evaluate true or false. So in this case, time is 9, right? So we're saying is 9 less than 8. That is false. So we would decide that I cannot go to the movies. Let's say we're asking the question, have I won the game? I have if my score times my lives is greater than 10. So now we're kind of looking at 2 variables, right? So we're saying if score times live is greater than 10, I have won the game. If this evaluates to false, then I have not won the game. So on this one, they give you some like tests. If you were in class, I would have you run through these with a partner. We're just going to do test 1. So we know score is 3 and lives is 3. So I have score of 3 times lives 3. 3 times 3 is 9. 9 is not greater than 10, so I have not won the game. If you want, you can pause the video here. You can run it through for test 2, test 3. Again, your takeaway is kind of what they want you to understand is that you have variables that have values. You can use those variables in your Boolean expressions using these comparison operators to evaluate to true or false, essentially making a decision on whether something's going to happen or it's not going to happen. This one, is my dog older than me? If his age is converted to human years, 1 dog year equals 7 human years. So they've kind of written this one out for us. We have the dog age, we have my age. Here is my diamond or my decision that I'm going to make using those comparison operators and this Boolean expression to decide if this is true or false. What we can do is we can make multiple decisions at one time, right? So this one's saying, can I adopt a cat? But this time there's 2 things that are going to have to be true for me to be able to adopt a cat. So we're saying I can adopt a cat if I have $40 and I am over 14 years of age. And one thing I want to point out is you have to read these pretty carefully, because this first one, I can if I have $40. That does not say if I have at least $40. It does not say if I have less than $40. It doesn't say if I have more than or equal to 40 or less than or equal to 40. It says if I have 40. So this means you would have to have exactly $40 and be over 14, right? So if you're 14, you cannot. You have to be over 14. So it's not a greater than or equal to, it's just a greater than. So if we were looking at this, I could assume that I'm 17 years old and I have $39. So you can see our flowcharts kind of expanded a little bit because now we have 2 decisions to make, right? So this one has to be true and this one has to be true for me to be able to adopt a cat. In this case, my age is 39. Or sorry, my age is 17. 17 is greater than 14, so that is true. So now I'm going to look at my money, which is 39, and it's asking is 39 equal to 40, because I have the 2 equal signs. 39 is not equal to 40. That is false. So they would say, I cannot adopt a cat. So the idea of having 2 Boolean expressions, right? To do this, we use logical operators. So that is either the and, which in code is 2 ampersand or 2 and signs, or, which is 2 pipe characters, or we have not. All right, so there are 3 logical operators, and, or not. When we write these in our code, we could use the word and, or the 2 and signs, the word or 2 pipes, or the word not, or the exclamation point. And what this gets to is kind of this question over here. So we're saying if our left side is true and our right side is false, what does this entire expression evaluate to? All right, so in this case, it evaluates to false, right? But how did I know that? What we do is we look at truth tables. All right, so these truth tables, if I was you, I would kind of write these down. There's going to be 3 truth tables that I'm going to go over right now. You need to know how these work. And the only thing that I can think of to give you some like real world, explanation of this is if you've played Minecraft, which I'm sure a lot of you have. There are pressure plates in Minecraft, and you can set these pressure plates up to open doors or close doors, and sometimes you have multiple pressure plates. So this idea that like you might have 2 pressure plates in front of a door, and that door will only open if there is a character on both sides, then the left side would be true because a character was standing on that plate. The right side would be true because a character standing on the plate. As long as both are true, the door would open. So some of you probably have some experience with this just because of Minecraft, but this is how these work. All right, so we're looking at the AND truth table right now. So if the left side is true and the right side is true, that expression will evaluate to true. If the left side is true and the right side is false, this entire expression evaluates to false. If the left side is true and if the left side is false and the right side is true, the entire expression evaluates to false. And if the left side is false and the right side is false, this entire expression evaluates to false. So again, I would write this down on some note paper somewhere because you kind of have to memorize these. But just at the end of the day, for the AND truth table, remember, the only way for the entire expression to be true is if the left side and the right side are true. So we then look at the OR truth table, because this one is different. The OR is almost the exact opposite of the AND table. So if the left side is true or the right side is true, the entire expression is true. If the left side is true and the right side is false, the entire expression is true. If the left side is false or the right side is true, the entire expression is true. And if the left side is false or the right side is false, the entire expression is false. All right, so you will basically get true as long as one side or both sides are true when you use the OR logical operator. The only way to get a false out of this expression is if the left side is false and the right side is false. All right, so again, left side true or right side true, it's true. Left side true or right side false, true. Left side false or right side true, true. If the left side is false or the right side is false, which is basically they're both false, then it's false. All right, the AND table is a pretty simple one because this not is just going to give you the opposite. So if something is not true, it's false. If something is not false, it's true. We don't use not a lot in this class, but we do use the and the or all the time. So kind of getting back to this question, can I adopt a cat? I can if I have $40 and I am over 40 years of age. We're going to rewrite this into a simpler flow chart where we have our two variables, money and age. But unlike last time where we had an initial decision to a second decision, we're just going to write it as one decision using the AND logical operator. So this is saying if money is equal to 40 and age is greater than 14. So for this example, we're going to say that they're 15 years old and they have $40. So we know that money is 40. We know that age is 15. So 40 equal to 40. This left side is going to evaluate to true. The right side, 15 greater than 14, that is going to evaluate to true. And then using that AND truth table, I can see if the left side is true and the right side is true, this entire expression is true. All right, so in this case, you would say true, I can adopt the cat. So this idea of a flowchart, we don't use it a lot in this class, but I will tell you that there will be one or two questions on your AP exam where they give you a flowchart with some values and some variables, and they're going to ask you to evaluate that expression using the flowchart to decide what the correct answer is. You will also have to produce one of these on your Unit 4 project. Right, there's going to be a planning guide. Your project for Unit 4 is going to have you making a decision. In that planning guide, one of the steps is to create a flowchart. So you would have to list whatever variables you come up with, the decision that's being made inside of the diamond, and then if it's true, what happens, and if it's false, what happens. All right, so just kind of understand these are your variables. This diamond's your decision. And then these two boxes down here is what's going to happen if it's true and what's going to happen if it's false. So as you start getting into the lessons this week, which there'll be videos that you can watch after this to kind of go through those lessons and help you, remember that we have these operators, right? So we had the plus side for and, we had the minus sign for subtract, we had the multiplication sign to multiply, and then this forward slash for divide. There is another operator, and it's called mod. Mod stands for modify, and in coding we use it as the percent sign. So add, obviously 5, subtract 1, multiply, we'd get 6, divide, we're going to get 1.5. So what mod does is it returns the remainder of this expression. So this is basically saying 3 mod 2. So we're saying if we take 2 and divide it into 3, what is the remainder? Right, so we know 2 goes into 3 one time, it has a remainder of 1. So if we had this in our code, it's going to evaluate to 1. All right, so mod just returns the remainder of that division problem that we're looking at. So if I had 17 mod 5, that's saying if I divide 5 into 17, what is the remainder? All right, so I know 5 will go into 17 3 times. 17 minus 15 is going to give me a remainder of 2. So 2 is what this would return. All right, so anytime you see this percent sign or you see that MOD that is talking about mod, which is a operator that we can use to get the remainder of an expression, right? And students are always asking, like, why would I use this? We actually use this in code quite a bit. It helps us determine if a number is even or odd. So we can say, you know, some number mod 2 and ask, is that equal to 0? So I could say like 10% 2 and then 2 equal signs and put a 0 to the right. That is a Boolean expression that's going to say if I take 10 mod 2, so 2 goes into 10 5 times, there is no remainder, so that side would evaluate to 0, and then I'm asking is 0 equal to 0? That's true, so I know that 10 is an even number. If it was 11, right, the left side would evaluate to 1 because 11 mod 2 is going to have a remainder of 1. 1 equals 0 is going to evaluate to false, so I know that it's an odd number. We can also use it kind of in the same vein that I was just talking about, but to determine if a number is divisible by another number. So as we go forward in this class, you will be using mod. It does tend to confuse students, so I'll just kind of keep reminding you that mod is that percent sign, and that's going to return the remainder from a division expression. So kind of some of your takeaways, right, for this lecture, because again, I'm going through this kind of quick. Normally you'd be in class with me for like a week or two kind of learning this. A Boolean value is a data type that's either true or false. We use these comparison operators, less than, greater than, to indicate a Boolean expression. So we're looking to see, does this expression using this comparison operator evaluate to true or false? Each side of the Boolean expression is reduced to a single value before we can evaluate that Boolean expression. So if I had 3 plus 1 equal to 5 minus 1, I have to do this side to get it down to a single value, evaluate the right side to get it to a single value before I can evaluate the expression. All right, we have these logical operators, so and, or not. Where we have to fully evaluate the left side to true or false, fully evaluate the right side to true or false, and then I would evaluate this entire expression using those truth tables. So true and false is going to evaluate to false, because on and the only way I can get true is if the left side's true and the right side's true. This one is an or, so if the left side's true or the right side's false, because one side was true or both sides were true, that's going to evaluate to true. Don't forget those truth tables. You need to write them down. Go back in this video, put your notes down for that so that you remember those truth tables. You can refer to them as you're going through this and building your own apps. And then just kind of remember a decision's made with a single Boolean value, right? So we got to get down to one Boolean value so that we can evaluate that expression. And then don't forget those flowcharts. That's going to illustrate the steps in making the decision. One of the things that we talk about a lot is this idea that you should plan what you're going to build before you actually start building it. So those flowcharts are part of that planning process, right? So we're going to, like when we plan for your project in 2 weeks, you're going to start with coming up with a topic. You're going to reach out to some peers to see what they know about it so that you can get that feedback, because that helps guide us in building an app that's actually helpful for people. We're then going to add in this idea of a flow chart and deciding the logical flow of our app before we start coding it. Then we're going to code it, and then we're going to get some more feedback to make some changes if we need to before we have a final product. And that is basically it for this lecture video. So again, I will see you at your weekly check-in, and if anything's not making sense, make sure that you reach out to me so I can help you.